So, welcome back. In previous lecture, we discussed mostly about the primary structures, and to some extent I covered the portion of the secondary structures also. Now, either you call structures or features which are preserved in the sediments, they are extremely important for us to differentiate between the non-tectonic and the tectonic. That was the main focus of this topic, and we will see few more examples of secondary features which are formed during the deformation. So, the slide which has been shown here, this was the last slide which we discussed, and you can clearly make out that how the primary features are been deformed and giving rise to a secondary feature. So, for example, what you are having here, the inclined stratification in the sediment succession is basically the primary feature, but now they are inclined, hence they becomes the secondary one, and they are also faulted along the fault plane here. So, you can see few branching out faults here and the deformation within the sediments, that is what we call the folding. So, if I just quickly draw it, then what you see here is that you have this one here which goes somewhat like this, and then you have another one which is coming and probably going like this one here. Okay. So, you have the deformation clearly. Now, another and on the other side of the what you see is the clear cut inclined stratification. Now, what another important part which will definitely we are going to talk in the coming slides is that there is a contact here which goes something like this here, okay, and again you are having the horizontally stratified sediments. So, what this contact is indicating is you have an unconformity, basically an unconformity, usually the terminology we use for which the process which marks the period of non-deposition and changeover from the one environment to another one. But here the contact with this contact basically is demarcating between the tectonic and non-tectonic. So, usually that sediments will get deposited in a horizontal fashion. So, whenever there is when next event will be there, the earthquake, then this the sediments will get deformed. So, for us basically the contacts, such contacts are important to identify the events, and basically what we talk about is the cross cutting relationship between the sediment layers. So, coming to the secondary structures, we couple of slides we have already covered in the previous lecture also, and the last one also was where we are talking about the secondary structures. So, secondary structure as the before deformation and after deformation, the sedimentary usually we see that the sediment layers or the deposition usually result into the formation of horizontally stratified sediments, and when they are subjected to deformation, here it has been shown in case of the metamorphic rocks. So, the metamorphic rocks when or the sedimentary or igneous rocks, when they are subjected to deformation, then they will develop some typical structures which are formed with respect to the stress pattern, and those are termed as foliations. So, the secondary features, as we discussed in the previous one, that the primary features are the features which are formed at the time of deposition, but the secondary features are after the deposition, which those are subjected to tectonic forces. So, if you take the definition in a broader sense, then we have that the sedimentary structures are those structures which are produced due to modification of original primary features or structures. So, example we will see on surface as well as within the sediment succession or rock succession are the folded layers or deformed beds in sedimentary rocks as well as in metamorphic rocks, development of fractures and joints. So, along with that we will also come across the development of fractures and joints, and if we see the fractures with the displacement, then we term those features or the structures as faults. Now, when we study the sediment successions to identify the events and to differentiate between the primary and secondary features, then as I told in the previous slide that we take into consideration the contacts. Okay. And here, so we have to be extremely careful while tracing the primary features and then where they are exactly getting abetted or disrupted, and those contacts should be marked and try to understand whether those are primary features or secondary one. Now, this slide, this succession which has been exposed is from Great Run of Kutch, mostly the tidal deposits. So, that is one of the reason why you see the fine laminations here, but they are not they have not remained with their previous like original primary state, but they have been deformed. Okay. So, I will slowly explain this, that how, and within this exposure what we see is mainly primary as well as secondary features. So, one has to be extremely careful. Now, suppose we start looking at the whole section here, then the prominent one, the contact, the sharp contact which comes to the eye is this one here. Okay. So, this is a very sharp contact which goes here, and initially we can negate or we can say that could be this could be a primary feature, but later on or you can try to justify whether it is non-tectonic or a tectonic feature. So, let us say that this contact could be a primary feature, and then look at the other features which are present within this section. So, if we just put a line here, or maybe later on I will remove the line here, then what we see is this goes somewhere here, and then there is a line here where there is an this part and this part does not match, because what we have understood until now that the sediments will be horizontally stratified, but there is some break here which indicates that there is a displacement. And if you carefully see this here also along this line, then we are having what we call the microfaulting. So, this layer is sitting here. So, there is a very fine line which goes here like this, okay. And then there is another one which goes here. So, there is a displacement. So, if you compare this one here, this lines these are slightly down here, but this is sitting here, and then even this one. So, there is a clear cut faulting which has been seen here as well as in this portion also, and there are many such features or the line of what we can say the secondary faulting which has occurred here. There is another one which sits here somewhere. So, the other part which we will try to look at this feature, and this goes somewhere over here and abuts somewhere here. Okay. So, this is a very typical of cross stratification we are able to see on this wall. So, this part is your primary feature, but what you see here at this part here, you have all crumpled material. Okay. So, you can see the material has been folded here and rotated, not in the preferred orientation. Okay. So, it has been rotated here. So, this portion we can say that this is a part of the secondary feature, and could be related to the plastic deformation. Okay. So, this is one indication of this. Okay. So, within this we are having some sedimentary feature. Even this you have a primary feature here, which is again a part of this two. What I have drawn here, the primary one, are your channel, small tidal channels. Okay. But if you carefully look at along this line, okay, there is a clear cut indication of deformation. Okay. So, you are having a displacement where this block has moved up, and there is slight deformation in this one. So, one can easily make out, if you carefully study the features which are exposed, or the sedimentary structures which are exposed on any exposed section, and try to make out and differentiate between the primary and the secondary one. Now, coming to further, so a few of the slides we have already discussed in the previous lecture about the primary and the secondary features, and more we will keep talking when we are getting into the details of the paleoseismic studies. But basic idea before heading into this topic is extremely important, because we have to be extremely careful in differentiating between the primary and secondary. Coming to the contact structures, in most of the hard rock terrains we will come across, and intrusive rocks also will result into a very sharp contact. So, this is basically the intrusion, that is your igneous rocks. So, contact structures are also been termed as, we can say, unconformities, intrusive contacts, and fault contacts. So, this two, that is unconformities and the fault contacts, we also say either the unconformities are the depositional or erosional unconformity, and then fault contact, as we were talking about, we are looking at the tectonic deformation. And intrusive contacts may be seen or observed along the fault contacts also, but mostly we see that they are just intruded into the country rock, and the intrusive intrusions are to some extent are very widely show wide extent. So, we may confuse between the intrusive contact and the fault contact also. So, let us see one by one, and some part we have already covered, and as I was talking in the previous one, that we also look at the unconformities, and that is within the sediment succession. If we have the primary one, then we may classify that as a depositional or the erosional unconformities, but in case of the tectonic, the fault contacts, we also say tectonic unconformity. So, this we will be able to see even in the in forms of the landforms as well as in terms of the sediment succession. And then we have shear contacts. So, these are the four major one. Again, this will form a part of the tectonic deformation. So, we have unconformities, intrusive contact, fault contacts, and shear contacts. So, what we have started right from the beginning, we are looking at the primary, secondary, and the contact structures. So, looking to the unconformity, as I told that we can have depositional, erosional unconformities, and we have even tectonic unconformity. So, if you carefully see this exposure which has been shown in the right hand side of the screen, and you see some very beautiful inclined stratification, and then on the top you are having the horizontal stratification. So, this also marks the change in the depositional environment, and these are termed as an unconformity. So, unconformity, if you define, it is one of the most common geological feature. So, you will see primary, secondary and or maybe you can say primary or second tectonic unconformities also. They are found in rocks or in sediment succession. It is different from all other geological structures, namely fold, joints and faults. Unconformities are resulted due to tectonic activity in form of uplift or subsidence. So, if there is an uplift or subsidence in any area, then this will result into the change in the environment, and this part of what we are talking about, the unconformities, we will be able to see more or we will try to show you when we are talking about the tsunamis and all that, and during the examples which we are trying to put forward for the mega thrust subduction zone earthquakes and the large earthquakes from the Sumatra Andaman Trench area. It is also referred to be a period of non-deposition. So, if you have, like, there is an deposition of this unit, this is not related to the tectonic activity, but in inclined stratifications, if you see, or cross stratification, and then there is it marks the end of this depositional cycle, and then you start having the horizontal stratification. So, change in the depositional environment also marks the unconformity or a period of non-deposition. So, there is no similar deposition has been taking place when these sediments were deposited. So, in a sketch, if you see, this is what we have. This we termed as an angular unconformity. We are having an inclined stratified sediment succession, and then we are having the horizontally stratified. So, for both the energy conditions are different. So, the environment, overall environment of the deposition environment changed over the time, and that marks the period of non-deposition or change in the environment, and indicated by a very prominent contact, and that what we term as an unconformity. So, even this cross-cutting relationship we take into consideration when we are talking about whether that is depositional or non-depositional period, or it is a tectonic one. Now, if you see the section which we opened in Kutch region. So, this again marks and very prominent features, where of course, these are inclined stratified, but we did not consider this as a primary feature, as I was showing in the previous slide. This part, okay. So, you have inclined stratification, and then you are having horizontal stratified material, and here also you can say that we see the inclined one, and then we are having a contact here prominent, and then we have the horizontal stratification. But we on the larger scale, when we looked at the section, what we found was that these units were deformed very prominently along this one. So, if you can I will just put the boundary here, and they are coming somewhere like this over here, and this goes somewhere like this. Okay. So, you have a very prominent deformation which has occurred along this line, okay. And this goes further. If I put this one here clearly, then you see this one here, okay. This goes like this, and then here. So, if you mark this one, it goes further. So, this inclination is not related to the deposition. Okay. It definitely got deposited in a horizontal fashion, and then there was a phase of, or the deformational phase. So, first the deposition in the horizontal fashion, then got inclined and folded because of the tectonic event, and then finally eroded along this line, that is this is the erosional contact, and you are having all horizontally stratified material. So, this is the phase of, so there is a deposition, hence this will become depositional contact, whereas this will become your tectonic contact. So, this tectonic contact is your fault. Of course, this we will consider as an primary features, but since they are deformed, we consider that as a secondary one. So, this unconformity, again we can also classify this as an angular unconformity. So, one has to take care about all these features when they are looking at the trench sections or the exposed sections, and try to understand whether they are tectonic or non-tectonic. Again, another exposure here, where you can try yourself also, but I'll just put, and slowly we can trace out the contacts. Okay. So, if we start from here, then this units are getting like this, bending here, and then abruptly turning down at this point. And then on this side, the other sediments are becoming horizontal. So, you can see the horizontally stratified sequence, but at some point you will be able to see a sharp contact which are indicative of folding. So, this is the bedrock here, then you have in sediment succession here. Okay. So, if you put the arrows here, then these are the fault planes along which the deformation has occurred. So, this again becomes tectonic contact, and along with that we also have the primary structures here. Intrusive contact are the contact formed by intrusion of igneous bodies into the country rock. Okay. So, huge intrusions which may go for hundreds of meters or kilometers. There is a view of Indus Valley, the intrusion of granite, sheet like features into the basic gabbroic rocks, okay, and the contact you can see over here. So, you may mark this contact as an fault contact, but this is not an fault contact, this is an intrusive contact. And another one, so the dikes, basically the contact formed due to intrusion of basaltic dikes in Precambrian sediment succession. So, such contacts could be on a very small scale, but such dikes can be of very large dimension also. So, we may not be able to see in one go the whole section. So, if you are just looking at this part on a larger scale, and then you may mistake this as a fault contact. So, one has to be careful about the different contacts which are available in nature, and need to be careful while identifying those contacts and differentiating. And coming to the fault contacts, we have seen a couple of slides in the previous slides. We tried to show you some fault contacts from the young deposits. So, basically the fault contact is a contact which develops due to slippage, okay, slippage of rock blocks or the sediment succession with respect to one another. So, on surface you will be able to see and very prominent displaced landforms, and in section what I have shown you in the previous slides. Okay. So, this is in the section here, you can see the fault contact where the two different rocks are been displaced here, or the rock succession has been displaced here. Another one, you can see the depositional feature over here are the sediments, and then you have the displaced layers along this one. So, these are the difference between the fault contact and the depositional contact. In the hard rock, if you see, then again the basic idea or the technique which one should apply here or to any exposed succession is that we try to like fix our eye on one particular very prominent layer and try to see its extent and how it goes, whether it is moving like it is extended horizontally or it is getting bended or getting abrupt terminated at along a particular plane or a contact. Okay. So, if you see this black one and the white one here, the rock layers, then you see that they are coming here and then getting into this one. So, this is a clear indication of fold, okay, and these are getting abutted along here, and then you have the horizontal one. And more prominently you can see the white and gray layers over here, they are all faulted. This mark is in watermark because this is a pond where this mark has come because of the water which was stagnated here, but this goes further down here in this direction. So, this is a clear cut deformation of like what we see the folding. Then the fractures, which we can say that they are secondary features, mostly seen developed on the crust part or the crust, okay, not, and then the trough we have. So, we will see mostly the joints, okay, and those joints are shear joints and the tensional joints. Okay. So, we have shear joints along the limb, and on the crust of the folds we will see the tensional joints. Okay. And if you see some displacement, of course, you can classify it as those as in faults, but these faults basically or the displacement, if you see along the shear joints, then such features you can classify as in faults, but they will be the secondary fault and they may not be the seismogenic one. Okay. Because we are interested in looking at the faults or the features manifested on the surface which will be responsible for triggering large magnitude earthquakes. So, further, like what we see in terms of the jointing on the surface because of the tectonic forces, and this we have already covered. So, I will just move ahead. Okay. Close up of that. So, what we see here is that of course, this one is in primary faulting. Okay. So, the main fault runs here, but along with that the deformation what we see here is shown in the next slide. The close up on is the micro faulting. Okay. So, you can see clearly these are also termed as faults, but they are micro features. Okay. And you can see clearly here this deformation, the layers are displaced, and you go further, there is some folding which has been shown here. So, these are all what we call as an micro faulting. So, they are not deep seated, they are just they will be seen within the succession. Okay. But major faults will be deep seated. Another example in the hard rock. So, as I was talking about the basic criteria to locate the discontinuity of the layers, either it is sediment layer or the rock layers or the beds, then we try to look at the physical properties, basically the color and the composition of the material we try to see. So, so this is from Kutch region, the exposed succession of the Mesozoic rocks. So, what we see is these are inclined towards this side, but they are getting abutted at this part over here. Okay. So, close up of that, if you see, is the whitish layer rocks you are having, which are sitting here on this side, on the right hand side, on the left hand side, they have been pushed up. Okay. So, what type of fault is this? We will try to discuss when we are talking about the different type of faults, but for your at present what we see here is I will just explain that. So, this contact, the depositional contact between this two rock layer is sitting somewhere here. So, these have been displaced along this one, and one more thing which of course we are going to talk later on, but when they were deposited or existed earlier they were horizontally, but when they were deformed we are able to see the displacement here. Okay. And at the same time this was like the flat surface at the time of deposition, but when they are deformed what you see is a development of a topography. So, this topography has evolved because of the displacement along this fault. Okay. So, this has moved in this direction up. Okay. Another contact here, you can see the folded units along this contact. So, this is a typical fold contact. So, I will stop here and we will continue in the next lecture. Thank you so much.